Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of points using the Solid Edge software. So in the previous video, we have seen a couple of problems pertaining to the first quadrant and we'll continue with the same set of problems in this video also. So the problem statement here is there is a point S in the first quadrant and is equidistant of 50 mm from all the three principal planes, and we need to draw the projections of the point, and all the three views of the point must be shown. So we can just understand that here the point S is in the first quadrant and it is equidistant. That means what? It is at a distance of 50 mm from all the planes, that is the vertical plane, horizontal plane, and the right profile plane, and also the left profile plane. So this is the uh, details that is given to us regarding the point. Yes, and then we need to draw the projections of this point. So we can solve this problem in two cases. That is, the point is at a distance of 50 mm from the RPP. That is the case one, where that is the left side view is recorded. And we can also tell that the point is at a distance of 50 mm from the LPP, that is the left profile plane, and the right side view is recorded. So we'll see how to draft the solution for this. So we'll begin with drawing the XY line. So go to the sketching mode and select the line option and ensure the thickness of the line here is 0.18 mm for the XY line. So let us draw the XY line. Go for the annotation and ensure you're using the Times New Roman font. And let us annotate the reference line as XY and the planes as VP and HP. So since we are going to draw the profile views also, we will consider drawing one more line, and that is x1 y1. So let us annotate this line as x1 and then y1. So now let us just locate the point in the first quadrant. So select a line of thickness 0.13 to draw the projections of the point. So from the HP, it is at a distance of 50 mm. So we'll record the front view at a distance of 50 mm on the VP. Similarly, the point is 50 mm in front of VP and the top view is recorded at a distance of 50 mm. And also we have to tell that the distance of the point is at 50 mm from this profile plane. So we will just go and measure the distance between this locus line and this x1 y1 line. So it is 42.63. We'll just change it to 50 here, and you can just see that the length is now adjusted. So the distance between the projectors is now adjusted. So from the profile plane, it is at a distance of 50 mm. So we shall use the smart dimension. This is 50 and this is 50. So now what we can do is we can go select the point option here, and then the point width could be 2.5 mm or 2 mm, and then we'll place the point at the end point of these projection lines. So this is the location of the point. So we shall annotate the front view as S dash or S prime and the top view as yes. And now we need to draw the profile view of the point. So for that, we shall follow this procedure. So select the line of thickness 0.13 mm. So from the point of intersection, so you can just see the intersection symbol here next to the cursor. So let us draw a line at an angle of minus 45 degrees. And then from the top view, consider intersecting this 45-degree line, and from that point of intersection draw a line perpendicular to the xy line and extend it up all the way in the vertical plane. So since the side view is always next to the front view, so from the front view, let me draw the line and intersect this projection line. Use the trim option and just cut off this. Now let us go for locating the point. So select the thickness of 2.5 mm and place the point at the intersection of these two projection lines. So we can just ensure that the projection lines are not crossing the annotations. So just keep them separate. Now in the annotation, we have got something called as the leader option. So let me select that. In the properties, I'll change the color of the arrowhead to black and click OK. and show the directions of the projection line. That is, from the top view, I've drawn a projection line in this direction, and from the point of intersection, I've continued drawing the projection line upwards, and then I've taken the projection line from the front view, that is, from the left hand side to the right hand side, and this point of intersection is the right side view of the point S, which is given by S double dash. So with this, we complete the first case, that is, we have recorded the right side profile plane and the left side view is recorded. So we'll just name this as RPP. The plane is RPP, and the view that is recorded is LSV, which stands for the left side view. Similarly, we shall solve the case 2 now. So we shall continue drawing the XY line of thickness 0.18 mm. So this is the XY line, and I'll also draw one particular line, that is the x1 y1 line. Okay, so now let me go for annotating this. So I shall select the text option from the annotation. So this is x and this is y, that is the reference plane. So use the capital letters to do the annotations of the reference line and also the reference planes, that is vp and hp. So this also needs to be capital. So just go for the annotation and label this as x, and this particular line to be labeled as x1 and y1. So now we shall continue the same procedure. So go for the width of the line, change it to 0.13. So 50 mm above HP, I'll record the front view, and 50 mm in front of VP, I'll be recording the top view. And then use the distance between this x1 y1 line and this line. So it is 52.38. I'll change it to 50. So now you can just see that it is adjusted to 50 mm. Let me go for the smart dimension. So the distance here is 50 and this is also 50. So next thing is I need to draw the side view. So for that, let me select the line option, and from the point of intersection, I'll be drawing a line at an angle of minus 135 degrees. So go for the angle between. So select this median line and this x1 y1 line. So this is 45 degrees. So now let me just select the point option, and the thickness of the point will be equal to 2.5 mm, and I'll place the point yes and in the vertical plane and the horizontal plane like this. So let me just annotate it. So this is the front view of the point S given by S dash. Use the small letters, that is S dash, and here this point is the top view of the point is given by the letter S. Now select the line option. Ensure the thickness is 0.13. So from the top view, let me just intersect this. So you can just see that it is not meeting. So let me just intersect by using the extend to next option. So there is something called as extend to next. So let me just use that option, extend to next. So this is extend to next. I'll extend this line, and from this point of intersection I'll be drawing a line upwards. So I need to extend the xy line also. I'll use the extend to next option, extend this. So let me just select the first view of the point and just move it aside. So there is an option called as move, and ensure the copy is off, and just select one particular point and just move it. So you can just see that the entire figure is moved. So now this is the xy line. So use the line option again, ensure the thickness is 0.13, and from the front view draw the line to intersect this projection line, and the point of intersection is where I'll be getting the side view. So trim this. Now I can go for point, select the thickness of the point to be equal to 2.5, click enter and place the point here. So this is the right side view of the point given by S double dash. In the annotation there is leader option. So let me select the leader option, change the color of the arrowhead to black, click OK, and indicate the directions of drawing the projection lines. So upward, and this is from RHS to LHS. So with this, we complete the problem wherein the point S is equidistant of 50 mm from all the three planes, that is 50 mm above the HP, in front of VP, and from RPP as well as LPP. So this is LPP, which means the left profile plane, and the view that is recorded is RSV, that is right side view. So with this, we complete the problem. We'll move to the next problem statement. So he tells that there is a point L which was initially 20 mm above the HP and 30 mm in front of VP. If it is moved to a position 10 mm below HP and 25 mm behind VP, draw both the initial and the final orthographic projections of the point L. So now let us consider this problem in two cases. So select the thickness of the xy line as 0.18. So let me draw the case 1. So draw the xy line first. So here there is no details given about the profile planes, that is the right profile or the left profile plane. So let us not worry about that. So we'll just consider the two reference planes, that is VP and HP. So it tells that initially it is 20 mm above HP and 30 mm in front of VP. So let me select the line of thickness 0.13 and draw the front and the top views. So it is 20 mm above HP. So I'll be recording the front view there, and then 30 mm in front of VP. So I'll be recording the top view in the horizontal plane. So use the annotation. Annotate the reference line as X and Y and the reference planes as VP and HP. Go for the smart dimension. Show the location of the point 20 mm above HP and 30 mm in front of VP. And then let us annotate the point. So this is the front view of the point given by L dash, and this is the top view of the point given by small l. So let us locate the point, select the point, change the thickness to 2.5 mm, and place the point at the end point of these projection lines, and this completes the problem. So in the first case, the point L is in first quadrant. So he also tells that it is moved to a new position, that is 10 mm below the HP and 25 mm behind the VP. So we can understand that the point L is in third quadrant now. So let us see how it is drawn. So select the line option, select the thickness as 0.18 mm, draw the XY line, that is the reference line, go for annotation and annotate the line as X and Y. So since it is in third quadrant, we do understand that the horizontal plane now goes above the xy line and the vertical plane is now below the xy line. That is the vice versa of the first quadrant. So now let us select the line option again. Thickness of the line is 0.13 mm. So he tells that it is 10 mm below the HP. So below the HP, I'll be recording the front view. So the front view is in the vertical plane. So this is 10 mm below the HP, also 25 mm behind the VP. So I'll be recording the top view on the horizontal plane. So go for smart dimension, show the length of the projection lines. So that is 10 mm and 25 mm. And then go for the point option, select the point thickness of 2.5 mm and place the point at the end point of these projection lines. And then let us annotate. So the top view is L and the front view is L dash. So this is the front view. So now you can just see that the point L is in third quadrant. So L is in third quadrant. So what we understand here is the first quadrant and the third quadrant are exactly the opposite. That is, the front view is vertical plane, that is above the xy line, and the top view is in the horizontal plane, that is below the xy line. But whereas the point L, when it is shifted to the third quadrant, the views are exactly mirrored to this. That is the interchange. The HP is above the xy line, and that is the top view, and the front view is in the VP, which is below the XY line. So with this, we complete the problem. So this is the initial position of the point L, and this is the final position of the point L. We'll move on to the next question. So in this problem statement, we have a point D which is situated 50 mm above the HP and 20 mm in front of the VP. Draw the front view and the top view of the point D and determine its location in the orthographic projection planes. So the moment we understand the location of the point, we can easily tell that the point D is in the first quadrant as it is above the HP and in front of VP. So now let us show it pictorially. So select the line of thickness 0.18 mm, draw the XY line, go for annotation, select the text option, annotate the reference line as X and Y and the planes as VP and HP. Again, select the line option, select the thickness of 0.13 for drawing the projections. So from any arbitrary point, draw a line of length 50 mm above the HP to record the front view of the point, and then 20 mm in front of VP to draw the or to locate the top view of the point. Select the point option, change the thickness to 2.5 and locate the point at the end points of these projection line. Also annotate. So the front view is D dash and the top view is D. Use the smart dimension and show the length of the projection lines that we have created. So that is 50 mm above the HP and 20 mm in front of VP. So we can just enter the position that the point D is in first quadrant. So with this we complete this problem. So next is the top view of a point A is 35 mm above the XY line and its front view is 20 mm below the XY line. So here he is not mentioning regarding the reference planes, but he is telling the position of the point with respect to the XY line and the views. So the top view is above the XY line and the front view is below the XY line. So this is a case of third quadrant wherein we get the top view above the XY line and the front view below the XY line. So now let us just draft the solution. Select the line option. The thickness of the line is 0.18 mm. Draw the reference line initially and annotate the reference line as X and Y and the planes as HP and VP because it is third quadrant. And now let us draft the solution to locate the point. So it is the top view is what 35 mm above the XY line and the front view is 20 mm below the XY line. So go for smart dimension, show the length of the projection lines 35 mm above the XY line, 20 mm below the XY line. So go for the annotation, and this is the small a, which is the top view of the point, and this is a dash or a prime, which is the front view of the point. So let us locate the point, select the point, thickness is 2.5 and place the point at the end point of these projection lines. So this is the top view of the point A, which is 35 mm above the XY line, and front view of the point is A dash, which is 20 mm below the XY line. So I can tell that the point A is located in the third quadrant. In the next question, there is a point R which is 25 mm above the HP and 20 mm in front of VP. Also, there is one more point S is on HP and 30 mm behind VP. The distance between their projectors is measured parallel to the line of the intersection of VP and HP is 50 mm. So we need to find the distance between the top views of the point R and S. So we have to draw the common XY line to locate the point R and S. So we shall draft the solution. Select the line option. Select the line of thickness 0.18 mm. Draw the XY line. Annotate the line as X and Y. So now select the line of thickness 0.13. So we shall take one by one. So first we shall locate the point R. So 25 mm above the HP. And next 20 mm in front of VP. Correct? So select the point option. Change the thickness of the point to 2.5 mm. and place the point at the end point of these projection lines. Go to the smart dimension. So this is 25 mm above the HP and 20 mm in front of VP. So with respect to the point, that is R, this is R dash, and this is the top view of the point R, which is given by R. So only for this point I can annotate the reference planes as VP and HP. So this is in the first quadrant. So you can just delete this text box and place HP below VP. Okay. So point R is now identified. 25 mm above the HP and 20 mm in front of VP. So the point R is in first quadrant. Now let us take up the point S, which is on the HP and 30 mm behind the VP. So since it is on HP and behind the VP, the point could be either in the second quadrant or it could be in the third quadrant. So now we shall draw the projection of this. So but there is also one more clue. So he tells that the distance between their projectors is measured parallel to the line of the intersection of VP and HP. So as you can see this, the line of intersection of VP and HP is nothing but the reference line. So the end distance between the R and the S is 50 mm. So now we shall simply create a line for reference 0.13 mm and draw like this, and then measure the distance. So this distance is 50 mm. So this is what is given to us. So we shall just locate the text so that they're not intersected by the dimensioning lines. So this is VP and this is HP with respect to the point R. So this distance is now 50 mm. So this is where the locus of the point S lies. Okay. So he tells that it is on HP. So once the point is on HP, I can understand that the front view is on the XY line. So the point of intersection of these two lines is where the point S lies, correct? And next it tells it is uh, 30 mm behind the VP. So behind the VP, I'll consider it to be in the third quadrant now. So let me just go for the annotation. Is on HP. So this is S dash is the front view. So I'll select the top view to be uh, so select a line of thickness 0.13 first, and then from here I shall draw a line of length 30 mm behind the VP. So let me select the point option. Thickness is 2.5. So behind the VP, so I've drawn a line of length 35. So I'll just place the point here. Go for the smart dimension. So this is what? This is the top view. So I've considered the point to be in the second quadrant. Correct? So now the distance between the top views is what? So I can show the distance between the top views, that is the top view R and S. So this is the distance. Okay, so this is the distance which is equal to 50 mm. That is considering the point to be in the second quadrant. So this is the first case. Now I can also locate this point in the third quadrant and tell that the top view is again on the VP. So uh, we can just locate the point. Again, it will be in the same location. So the front view is here and the top view is here. So we can just go for line option 30 mm behind the VP. So the top view is recorded here. So it is the same. So we can just go and measure the distance between the top views. So it is 50 mm. So this is the required solution to find the distance between the top views of the point R and S. So with this, we complete drafting the solutions for all the 5 problems. So in this video, we have just covered how to locate the point equidistant from all the planes. And next, we have taken the initial and the final position of the same point in different quadrants. And then we have located a point in the first quadrant. And in the next problem, we identified a point in the third quadrant. And next, we have got the point in the first quadrant and as well as in the third quadrant. And we have found out the distance between the top views of that particular point. So with this, we complete a video in which we have understood the position of the points in different quadrants. Thank you all for watching.